Here we go. So we're on 3B.2, notes of factoring trinomials. Okay. So really quick, as a class, how do we feel about GCF? It's doable. Okay. How do we feel about identifying the factors? Okay. Those are all the skills you need for today. All right. It's just going to look a little different. Okay. A little different. All right. All right. I call this method Xbox. It's called Xbox. It's called Xbox. Okay. So with this method is a visual way of being able to factor. However, we will also learn from my non-visual learners. You're like, miss, that's too much drawing for me. Then we'll do it another way. But 9 times out of 10, most people like Xbox just because it helps you organize your thoughts. Okay. So up first, we have 4x squared minus 15x minus 4. Notice that our A is no longer 1. It's actually equal to something, right? So that means we have to take it into consideration, okay? So the first thing you're going to do is make sure there's no greatest common factor. Is there a greatest common factor between those three terms? No. Womp, 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 okay? Next, you're going to identify your terms. Your A term is always going to be with your x squared. So that's going to be 4x squared. Yes? Your B term is always going to be your single x. So our B here is negative 15x. And your C is going to always be your constant, the number that has no variable, which is negative 4. Okay? Now, because of A, we can't just ask what multiplies to give us C anymore. We have to ask what gives us C times A. Okay? Because there's an A now, we have to ask what multiplies to give us C times A. So what is C times A? 4x squared times negative 4. Negative 16x squared. 4 times negative 4 is negative 16. And we still are asking, but adds to give us negative 15x. So we're looking for what numbers will multiply to give us C times A, but add to give us B. What two numbers will make this work? Perfect. Negative 16x and a positive 1x. Do we all agree? Yeah? Okay. So this is where we're at now. Now we're going to fill in the box. In the box, it's always going to be your A term, your C term, and your numbers from the X. So your A term, your C term, and your numbers from the X. So A was 4x squared. C is negative 4. And my numbers from the X are negative 16x and 1x. It doesn't matter where you put the numbers from the X at, as long as they're in one of these two boxes. Once everything is in the box, all you're doing is greatest common factor for every row and every column. So in our first row, what is our GCF? 1 what? 1x. And our second row, what is our GCF? What kind of 4? It's going to be negative because the outside is, the first term is negative. And this row, column, 4x. And in our last column, 1. They're just 1. So therefore, your factors are x minus 4 times 4x plus 1. And you're done. Remember how I asked you, how did we feel about GCF and finding factors? Oh, yeah. That's all you had to do. Okay, are you ready to do example 2 at your table? Okay, I'm going to leave this example up here so you can look back at it. But at your table, you're going to do example number 2. Okay? Okay? A is always the term with your what? X squared. Your A is always your term with your x squared. Boy, you do this practice problem. I'm leaving the example on the board so you don't have to flip back and forth. C is always a term without a variable. Your C is your term without a variable.
15 times 15x.
See what you did? Oh, you wrote it on the wrong one? You can just change the model. No, you're not cooking. He is. You are cooking. He's doing it. They're just hating on you. Alright, okay.
Who is they?
How we doing, girls? So remember how we did part 3 and part 15? If they have something to divide up, students will not.
Yeah, this next year. That's all.
Coming down, coming.
Got it?
We got this part down, okay? So what's your two numbers? Just 10.
15
Oh,
x.
this one. What's 15 times 1 is 30? So this would be your 15x, no, your 2x. And you double check it, so I'm making sure. Does 15 plus 2x equals 17? Does 15x times 2x equals 30x? That's how you know you did it. Okay? Easier than
So you got the wrong x. 30x minus 1x.
Are you doing feet? Doing the breaks? I'll take you either. Definitely the one.
Why is mine?
I'm sorry.
You're more of a child. You literally left it.
Huh?
Oh. I didn't.
All right, are we ready to check?
Yeah.
You gotta do
I did something.
So it's 3. Looking at this code. But they have a big problem. All right, let's look at example number 2 and see how we did. So in example number 2, was there a GCF? No, there was not. There was nothing I could divide out. My A is always with my x squared, which is 6x squared. My B is always with my x, and my C is the lonely one. Okay, because A is greater than 1, I have to take it into consideration. So C times A makes what? 30x squared, and I still need them to add up to equal my B, and my B is 17x. So what two numbers multiply to give me 30x squared, but add to give me 17x? Perfect. 15x and 2x. And I double check myself. 15 plus 2 is 17. 15 times 2 is 30. So in my box, it's your A, your C, your X, and your X. So A is 6x squared. C is 5. And I have 15x and 2x. Remember, you're doing greatest common factor. It doesn't matter which one you write the boxes in. And now you're going to do your greatest common factor of every row and every column. And my first row, my GCF is what? Anybody? What's my GCF on my first row? 2. Now, is yours going to be different than mine if you put 15 up top? Yes. My 15 is here. So mine is my 3x would go here. The inside doesn't, but once you find the greatest common factor, it's going to play itself out. What's 15x and 5? What's their GCF? 5. And what's the GCF between 2x and 5? Do they have one? It's just 1. So my answer is 2x plus 5 times 3x plus 1. If I didn't feel good about it, what would I do? I would check myself before I wreck myself. Okay, so this is considered, guys, this is considered the new school way of doing it, right? This is how grouping is how it was done back in my day, my old times. Okay, it takes away the visual of it, but it's the exact same steps, just without the X in the box. Okay, so as you look through this, do you have to do it this way? No. If you are comfortable with X in box, you can keep doing X box. Okay. If your algebra, no, you don't need it. If your algebra 1 teacher taught you a different method that you remember and you appreciate and you love so dearly, please use that method. Okay. We will pick up where we left off on Monday.